All right, so last time we were taking a look in section 2.2, we had done some of the algebraic, well, we did all of the algebraic portion for this section. And we were taking a look at some of the information about how to do these graphs. And just as a reminder, the specifics down here is where we sort of left off. Specifically, what we start to look at is where the slope's 0, and the slope is 0. Can you describe how you find a slope of 0? What does it look like on a graph? Okay, so the tangent line is going to be horizontal, right? But where does that actually occur on a graph? Peaks and valleys, very good. So we're looking for peaks and valleys, really, like maximums and minimums on number 1. Number 2 is almost like you're looking at the graph from left to right and you're interpreting information about whether it's increasing and decreasing. That's what you're really doing, but you're writing the information down in terms of what the slope is doing. And then there's number 3, when I told you we sometimes don't do it. In fact, often we don't do it. I'll show you today when that happens, but generally speaking, it happens when we don't have a lot of information from 1 and 2. Okay? This is the one that we had done last time. Does that look pretty close to what we did? We actually wrote down all of this information about slope, and then I had you mark them all out in a different color and write the word y value to help us think about what happens when the y value actually has these features instead of a slope having these features. And we're going to actually come back to this idea here in a minute when we get into 2.3 about what's going on here in terms of this graph. But let's move on to the next one before we get to 2.3 so that we can sort of see what's happening overall. All right, so here's our next graph. This is going to be like a lot of the ones you have in your homework. There's nothing labeled here. The last one I actually put in the A and the B as part of our labeling. So there is an important point here. It's the value that's the valley, right? That's an important point. So even if it's not labeled, you get to label it. So you just pick your favorite letter. Maybe you pick the letter Q. I like Q right now for some reason. So we're going to use Q. And you just put it on there. It's about the location that looks like the X value for that minimum. All right, so important features. What is the first important feature we look for? And the slope is 0. So on this one, the slope is 0 where? At Q, or whatever you called yours. Could be Z or whatever. Yeah, the slope is 0 at this point we labeled. And that's the only one, right? There aren't any other places like that. So how about we read the graph then from left to right? So if we're reading the graph from the left until I get to the point Q, what can you tell me about those slopes? They're negative. Like the graph itself's decreasing, but not the slope. The slope is actually negative at all those locations, right? If you drew all those tangent lines in like we did back in 2.1, all those tangent lines would be slanted lines that are going downhill, having a negative slope. So the slope is negative from negative infinity to Q. Or you could actually even say it looks almost like that it's from 0 to Q because that's the only part of the graph that we actually see. Either way would be correct. I kind of have the feeling that the way this is probably drawn, that the graph eventually crosses the y-axis. That's what it sort of looks like to me. But if you interpreted that differently, it would be okay because you don't actually see that on the portion of the graph you have. And then what happens after Q? Slope's positive, right? So the slope is positive from Q to infinity. That's actually as much information as we can have on this particular diagram. And unfortunately, it leads us to having several options for how we draw our graph. So I'll discuss a couple of those options. There's some things you do not have an option for, though. The first thing you do not have an option for is this issue about the zeros. So go ahead and change your color if you could, and change all the word slopes to the word what, or phrase what? Y value. So we're going to talk about Y values now that have these features. All right, so I need a Y value that's 0 at Q. Well, so far I didn't even put Q on my graph, so it looks like it's something like there. What does it mean to have a Y value of Q? I mean, a Y value of 0 at Q. On the x-axis, right? Yeah, the point at Q is actually on the x-axis, right? Because that's a Y value of 0. The second statement here where it says the Y value is negative before Q. What do negative Y values look like? They're below the x-axis. Very good. So what we don't know, however, is what the graph actually looks like below the x-axis, do we? We really don't have enough information based on the picture that we have to draw that. So there's a couple of things that you could draw that seem reasonable. One item that you could draw that seems reasonable is to simply make it look like a line. You could do that. Another item that seems reasonable is to make it look like it's sort of approaching that that y-axis, because you can't really tell on the graph originally if it really has like an asymptote there maybe, or if it's going to cross. So you could draw something like that. I am actually going to have mine drawn as a straight line because I want to make a connection for you later that will hinge upon that idea. If this graph in number 4 really is a parabola, like an x squared graph, then this really will look like a line. That's not an accident, and we'll talk about why. And then after Q, we have a y value that's positive, so what should be happening after Q? We're above the x-axis, right? And again, we have the same question as before. If we've drawn it as a line before Q, it should be a continuing line after Q. If you drew it so that it had this sort of a slanting down feature like the other one I drew, the other side should have had that sort of slanting up kind of a feature as well. So you wouldn't piece together two different sort of images on either side of Q. That would not sort of fit with the description. Because it very much looks like on number 4 that it's a mirror image on either side of Q, doesn't it? And so the graph's derivative should have the same sort of a look on either side of Q as well. That is either being straight or curved. Any questions on this one? Okay, somebody tell me what's going on this graph. What is this a graph of? It's not a trick question. What's it a graph of? It's a line. So a line has some interesting features. So if we're trying to sort of make a list like we had before, let's start at the first thing. Slope of 0. We don't have any, do we? So I'm actually going to jot that down just as a feature to remind ourselves that there is no 0 slope. There aren't any. Let's talk, though, about what the slope is. What can you tell me about the slopes that you do see? They're positive. The slope's positive everywhere, right? So that's important. What else? It's constant. That's really important, isn't it, Tyler? The slope is constant. So constant means that it's the same value no matter which value you pick. So for instance, if I was right here on the graph, or I'm right up here somewhere on the graph, no matter what that number is, it's the same number. It's the same slope. And it's the same slope because it's a line, right? I mean, nothing else has that feature where the slope's the same everywhere, just lines do. And believe it or not, that's enough information to draw a picture. So this number 2 is actually, or the last feature is actually kind of a number 3 issue. The fact is that the slope's not changing, and that's actually what 3 indicated that we were supposed to be figuring out is how the slope changes. Well, it doesn't. It's constant. All right, so I need to go back. I need to change the word slope to the word y value, or the phrase y value. All right, so I have no y value of 0, no zeros, which means I don't cross the x-axis, right? It's not going to cross the x-axis. This says the y value needs to be positive, so it means I need to be completely and totally above the x-axis, right? This last piece of information is actually the most helpful. This one says my y value is constant. What does that mean? This is a horizontal line. So a y value being constant, let me do it in this color, see if it draws okay. It's not too bad. All right, y value being constant means that it actually is the same value everywhere. Well, this is the same y value at every point along that line. It's a horizontal line. Those 3 examples that we've done already comprise to make up an argument that I'm going to take in a minute, but I want to show you a couple other examples before we get to that. So this one right here is interesting. It has some common features to things we've seen before, but it has some very different features too. So what can you tell me about this graph? Let's start with that slope of 0 business. What do you think? It's never 0, is it? But it looks like it's really close to 0 on the left, doesn't it? I mean, it's getting awfully close. to having sort of a flat tangent line, a horizontal tangent line, isn't it? It's really close over here. So while it doesn't really fit the information for number one, that's information that's helpful, so I'm going to jot it down. So while the slope is never 0, the slope is nearly 0 on the left, or we could say on the far left if you prefer. It's getting very, very close to 0 on the far left, the slope is. All right, so what can you tell me then if you read the graph from left to right about the slope? It's positive. This slope is always positive. Kind of like the last one, right? However, it is not a constant slope, is it? What can you tell me about this slope? It's increasing, isn't it? So if I were to draw in a couple of tangent lines to give us a point of reference, here's a tangent line, and then here's a tangent line, and then here's a tangent line. What can you tell me about the slopes of those lines? They're increasing, right? So the slope, this is like a number 3 feature. The slope is increasing as you move to the right. Or you could say as you approach x, or as x approaches positive infinity, or something like that if you'd like. All right, so my graph then, I don't need to have any sort of x's or a's or b's or anything labeled on the bottom because I didn't have any slopes of 0. But I do need to go back and I need to change the word slope to the phrase y value. I need a y value that is nearly 0 on the far left. So it needs to be really close to the x-axis on the far left, right? I need a y value that's always positive, which means the graph needs to be above the x-axis. And then I need a y value that is increasing as I move toward the right. What is this graph going to look like? You want to draw it, Grace?
It looks similar to that one, except a little bit lower, so like
Maybe.
a hole for 0, maybe.
Well, there's not a hole for 0
Because I can't get to 0.
because at the right here, which is where you're indicating there might be a hole, that piece right there does not have a slope of 0.
No, but I mean like if you were to draw the slope, because it can't be 0.
Give it a shot. Turn it around. There you go. Turn it around. Draw me what you think.
So like that kind of?
Okay, so there's some good features about what she's drawn. What do you guys think? What's good? What maybe do you have questions on or do you think didn't match what you were expecting? What do you think, Tyler?
I think it's the same graph as before.
You think it's the same graph as before? So part of Grace's graph is our same graph as before, isn't it? The only part that's different is this part where she's drawn right there. So I'm going to fix that piece of it in theory. That's not too bad. So this piece of your graph, Grace, is exactly right. Okay? But the way that yours looked made it look like you didn't actually move to the left at all. So our graph actually needs to continue to the left because the original graph continued to the left. Does that make sense?
Yeah.
So but it does still get really close to the x-axis down here, yeah? And Tyler's right. It looks an awful lot like the one we started with. We actually won't encounter, you won't encounter the equation perspective of how to do this until Calc 2. But we can still talk about the graphical perspective of why this works right now. And this is what happens. So this is actually the only graph that is fully has this feature. We have one other graph that is a very similar feature to it. And we'll encounter part of it on this particular graph right here. Whoops. Okay, that's not working. All right, so what about this graph is interesting or different? What do you see? There's some jumps in there, some discontinuities, right? Got lots of pieces. I've got a vertical asymptote too, don't I? That y-axis is acting like a vertical asymptote. That's important. Anything else? There's actually a vertical and a horizontal. Yeah, so I have a vertical asymptote that's the y-axis, and it looks like there's a horizontal asymptote, potentially at least as I move to the left. That's the x-axis, yeah. This one actually has sort of some hash marks indicating the locations of the x values, if you will, or whatever, so we'll use those hash marks like they are as though they're values of 1. They're not labeled, but let's go ahead and put them in just so that we can all be on the same page for what we're talking about. The y value scaling doesn't make any difference at all. It's just the x values that we care about. But let's do this a little bit differently. I actually have 4 pieces of this graph that I'm going to have to draw 4 graphs for. Make sense? So I'm not going to write out the full-blown 3 steps, basically, that we've been doing on each of them. But I am going to look at each piece of this and sort of identify some key features that maybe will help me to draw the sketch that I'm trying to do all over again on the other side. Okay, on the derivative of this. So what can you tell me about this particular piece, the far left piece? What do you see? Okay, so the slope, first of all, the slope is negative, right? Okay, so we have a negative slope. Anything else? The slope is becoming more negative, or the slope is decreasing. That's exactly right. And we say that to mean that that's what's happening, Micaiah, as we move from left to right, correct? So anytime we talk about increasing or decreasing, we're talking about a movement that moves us from the left to the right of a graph. We read a graph just like we read English. What else? There's one more feature that might be helpful to write down. Any thoughts? That's a good feature, and I'm going to write it down. That wasn't the one I was thinking of, but that is a very good feature. So we're not going to... and actually, the x-axis isn't the big issue. Actually, the y-axis is. It doesn't cross the y-axis. The other feature that I'm going to write down is that the slope is almost 0. Where? On the left. Which is part of what Grace was saying when she was talking about it never crossing the x-axis as well, is that we've got this sort of leveling off, or like that Tyler was saying about this asymptote feature over here on the far left. Okay, so I'm going to do these as we go and see if that will work for us. So as we go then, on the far left, what will the graph look like? Well, I need a y value that does these things. I need a y value that's negative, a y value that's decreasing, and a y value that's almost 0 on the left. What's it going to look like? It's going to look the same, yeah. And we will get to this particular piece of a graph, just a piece of it, but this particular piece of a graph and why that happens later in chapter 2. Yeah. All right, let's do the top piece now. So that's the left side of this graph. What about this piece right here? What can you tell me about this piece? Okay, so the slope is decreasing. The slope is negative. So let's go back and slope's negative. I actually don't think the slope's decreasing on this one. The graph's decreasing, the slope's negative, right? Slope's actually increasing, isn't it? Because it's very, very negative initially, right? Think about drawing those tangent lines in there. It's a very, very negative slope here, and then it's a much less negative slope here. So I actually think the slope on this one is increasing. Anything that's 0 or nearly so? Looks like we're getting awfully close to 0 at 3, doesn't it? We're getting really close to a horizontal tangent line there at 3. So the slope is nearly 0. At x equal 3. Awfully close to a horizontal tangent line. You might even be able to argue that you really think there is a horizontal tangent line there, and that would be okay. So we're either close to 0 or at 0 by the time we get to 3. What happens between 3 and 4? Well, actually, you know what? Let's draw that piece. I'm sorry. Let's draw that piece. So what will that piece look like? It won't look the same this time, actually. It will have some similar features to it, though. So all of our slopes become y values. The first one, the first piece of information tells us why it can't be the same. The y value is supposed to be negative, right? So where would that be? We need to be below the x-axis, because those are where y values are negative. Is everybody with me on that? So this graph definitely has to be down here somewhere. And then I need a y value that's increasing. So the only way it's increasing is that if it starts out down and it comes up. Okay? So it looks very much like we've got sort of just the flip of the graph. And you can either say that this gets really close to 0, or if you want to say that you really think it equals 0, you could actually hit the x-axis at the x value 3. So that's kind of your choice. So I'm going to say that it's slightly below, but that's just because that's what I chose. It's nothing important for you. Okay? All right, so this is the graph. It's increasing, it's negative, and it's nearly 0 or 0 at 3. Now tell me what's going on in these last two pieces, because they have almost the same picture. What's going on here? Can you tell me about the slopes? The slope is 0, right? And that's all there is to it. The slope is 0 from 3 to 4 and 4 to 5. So I should have probably drawn my graph in a red or something else so that I could actually differentiate it from the axes. Because what happens at 3 to 4 and then from 4 to 5 is that I'm actually on the x-axis. But there's something weird going on. Do you remember in the last lesson, the very last slide that we talked about is where tangent lines did not exist? And one of those places that they didn't exist was discontinuities. This graph is discontinuous at 3 and at 4. It flat out has a discontinuity there. So what that means is that it can't actually connect here sort of at 3 or at 4. So one way to draw that then is to say that I've got these open circles going on. It doesn't exist. The tangent does not exist at those points. Now your point at 5 could be a closed-in circle. It could be an open circle because we don't really have any other piece after 5 to compare it to, but it certainly looks like it ends. So it's up to you kind of how you want the 5 to end on that, but the rest of it actually has open circles at 3 and 4. Okay, so before we leave this, I want you to go back on the page to 3, 4, and 5. Because this is going to become really important when we get to 2.4 or 2.3. What would you guess that this graph on number 3 is an equation of? What does it look like from what you've seen in algebra before? Or maybe a pre-calculus class or something? Any thoughts? It looks like an x cubed graph. X cubed can take on various forms, but this kind of a graph could be an x cubed graph. That's reasonable. If this graph looks like x cubed, and we're going to say that it is for the moment for argument's sake, what does this graph look like? It looks like x squared. That's not by accident. So it looks like that when I take an x cubed graph, I end up with a tangent graph that looks like x squared. That graph looks like an x squared graph, doesn't it? And it looks like the way I've drawn mine, right, that when I take that x squared graph, it becomes a tangent graph that looks like an x graph, a line, right? The quadratic looks like it's becoming a line. This graph is a line. And it looks like when I draw the tangent graph for a straight line, and by straight I don't mean horizontal, I just mean it's an actual line, what we mean by line, that its tangent graph looks like it becomes a horizontal line with a slope of 0, right? Horizontal line. We're going to come back to that, and I want to talk about that when we get there. We've got one more problem to take a look at. This problem says to sketch the graph of a function with the following properties. Anytime there's a graph with some properties, it usually means that there's more than one way you could sketch it. Now, there are some features of it that better match between everybody's where that's going to be the incorrect part of it. Those features, we're actually told in this graph that we have some function values, And then we're told some things about slope. Remember these pieces right here have that prime notation, and that's issues about slope. Right, this is the slope of what's going on. The derivative is another way of talking about slope. So what we're going to do to start with is we're going to draw an xy axis, and we're going to draw in x values that are at -2, 0, and 4 at the very least, because our function values have information. We have information about those function values. And I think I'm going to go out one more in each direction just to give us a little bit of room to work on beyond that. And I need my y values then to go from 2, 3, and 1. So there we go. What in the world does this piece right here tell me when f of -2 equals to 2? What does that mean? Yes, there is a point on the graph at -2, 2, which is roughly here, right? Those ordered pair notations are the same as that notation that's given to you. It's just a different form. This notation says f of 0 equals 3, which means what? Yeah, at the x value of 0, I need to be at a y value of 3. So I'm right here. And then the last one up here tells me that f of 4 is 1. So over here at x equal to 4, I'm at 1. These are the unmovable parts of your graph that you're given, and everybody's will match. Now, there may be some variations after that because the rest of the information that you're given is actually telling you about slopes. This one tells me that the slope is supposed to be 0 when x is -1. Well, x is -1 is down here. What does a graph look like when it slopes 0? A minimum or maximum? And you get a pick. Do you want it to be a minimum or do you want it to be a maximum at this location -1? Somebody tell me a guess. I mean, there's not a guess. You get a pick. You want it to be a minimum. So that means that from wherever I start over here at this first dot until I get to this dot, I need to have a valley somewhere between them if I'm going to make it a minimum. And if you choose a maximum, it's okay because that's fine. I mean, that's another possibility. So my graph is going to look like this if I make it a minimum, which means that smooth and flowing, it's probably going to keep going to the left up on the other side. All right, the next piece of information over here tells me that at 2, at x equal to 2, I've got a slope of -3. Now, I'm not going to work too much about whether it's a -3, but the fact that it's negative is important. What is the fact that the slope is negative at x equal to telling me? What does the slope being negative tell me about the graph? It means it has to go down, right? It means that somewhere, wherever I am at 2, let's say it's here, it better be going like this. I have to have a slope that's going down or a decreasing graph. So somewhere here between this point on the x-axis and this point over here at the 4, 1, at 2, I need to be decreasing. Okay? So one way to do that would be to simply go like this. You don't know. I mean, so this made a sharp turn here, right? If you didn't want to make a sharp turn, you could do something like this. Right? At 2, I'm decreasing. And that'd be fine too. So whatever you'd like to do, as long as you're decreasing at the point x equal to 2, then you've satisfied the conditions you were given. Sound good? All right.